Questions 11 through 12 on the 2012 Grade 10 Cayley Math Contest. Matilda has a summer job delivering newspapers. She earns $6 an hour plus 25 cents per newspaper delivered. Matilda delivers 30 newspapers per hour. How much money will she earn during a 3-hour shift? $6 plus 30 newspapers times 25 cents per newspaper. That is what happens in 1 hour. So it's 6 plus 30 times 0.25 is 7.5. So $13.50 is what she's earning in an hour. Well, she has a 3-hour shift. So we take $13.50 and multiply by 3. And when you do, you get $40.50. So number 11, the answer is A. The point PQ is on the line y is equal to 2 over 5x as shown. Also, the area of the rectangle shown is 90. What is the value of P? Well, in this diagram, this is labeled as PQ, this point right here. So that means from here to here is P, that distance. And from here to here, or from here to here, whichever one you prefer, is Q. Now they have said that the area of that rectangle is 90, so that means Q times P is equal to 90. Now this point PQ is on this line, y is equal to 2 over 5x. So that means that PQ satisfies that equation. So when y is equal to Q, x is equal to P, like that. All I've done is just substituted that point into this equation. Well, Q is equal to 2 over 5P, so I can substitute that here. So instead of Q, I'll write 2 over 5P, and then multiply that by P. So this becomes 2 over 5P squared is equal to 90, and therefore P squared is equal to 90 times 5 divided by 2 if you cross multiply. And P squared, what is that? 450 divided by 2, so 225. And then if you take the square root of both sides, you get 15 for P. So number 12, the answer is D. There is one odd integer, n, between 400 and 600 that is divisible by both 5 and 11. The sum of the digits of n is. Well, if that number n is divisible by both 5 and 11, that means it's of this form, 5 times 11 times something, x, let's say, or k, whatever, right? So it's got to be 55k. So it's got to be some multiple of 55. Okay, no problem. You're allowed to use a calculator on the Canadian exams. I don't think there's anything wrong with using a calculator. So let's find multiples of 55. 55 plus 55, right? Do that on your calculator. And then get to the first one above 400, because remember, the number has to be between 400 and 600. And I get 440. That's the first number above 400 that is a multiple of 55. Okay? Then keep adding 55, you get 495. Add 55 again, you get 550. Add 55 again, now you're over 600, so we're outside of that range. So these are the only three numbers that we can consider. They're saying it's odd. Okay, well, 440, is that odd or even? It's even. 495 is odd. 550 is even. So of these, the only one that's odd is 495, and therefore that must be my n. Now they're saying the sum of the digits of n. Well, 495 is the value for n. The sum of the digits would be 4 plus 9 plus 5, and that is 18. So number 13, the answer is 18, and that is choice E. In the diagram, triangle PQR and STU overlap so that RTQU forms a straight line segment. What is the value of x? Lots of different approaches to this. You know, like I always say, whatever you feel is most comfortable. Let's see here. This is a right angle, right? So that means on this side, that's also a right angle. So this little guy in there has got to be 60. Because the sum of the angles of a triangle equal 180. So 90 plus 30 plus 60 is indeed 180. Okay? Now, opposite angles apply here. If this is 60, then that's got to be 60. It's an opposite angle. And then again, because the sum of the angles of a triangle add up to 180, this guy in here has got to be 70. I think I can fit that in there. Yeah, 70 right here. All right. So now we just have to look at this big triangle, and that's it. So the angles in that big triangle are 70, x, and this guy, which is a 90. And that's got to add up to 180. So that means x is equal to 20. And that's it. So whatever way you want to do it, this is a process known as angle chasing, where you use the fundamental property that all the angles of a triangle add up to 180, and then use other properties like opposite angles like I did there, and so on, to eventually come up with the value for the unknown, angle chasing. So number 14, the answer is 20, and that would be choice B. In the diagram, each of the two circles has center O. Also, OP to PQ, the ratio is 1 to 2. If the radius of the larger circle is 9, what is the area of the shaded region? Well, OP to PQ is 1 to 2, so if OP is x, PQ will be 2x. Okay. The area or the radius of the larger circle is 9, so the radius of the larger circle is OQ. So OQ is equal to 9. But OQ, according to my notation, is 3x. So that means x is equal to 3. So now, the area of the shaded region, AS, is what, right? How do you figure this out? Well, it would be the area of the big circle, so pi or big R squared, minus the area of that small circle. If you do that, you will get just the shaded region. So the big R squared, they actually tell you that in the question. That doesn't even need to be calculated. But the small radius you need to calculate. Small radius is just x, according to my notation, and x is 3. So that's 3 squared. So this becomes 81 pi minus 9 pi, and that is equal to 72 pi. And therefore, number 15, the answer is D. The equation y is equal to ax squared plus bx plus c was used to create the table of values below. What is the value of a plus b? Well, this, I believe, means that when x is 0, y is 8, and when x is 1, y is 9. It's interesting how they did it in the horizontal way rather than the vertical way, but it doesn't matter. All right, so let's substitute this guy first. X is 0 and y is an 8 into this equation right here. So 8 for y and then 0 for x, so I get 0 plus 0 plus c. So very quickly I get c is equal to 8. Okay, let's now substitute 1 and 9. So when y is 9, I get a plus b plus c, but c is 8. All I've done is just substituted these points into this equation. Nothing fancy. So now a plus b, if I bring the 8 over, is 1. And that's it. That's what they wanted me to figure out. So it doesn't need to be any more complicated than it should. Number 16, therefore, is B. A string has been cut into 4 pieces, all of different lengths. The length of each piece is 2 times the length of the next smaller piece. What fraction of the original string is the longest piece? So here's our piece of string, and let's see here. So we've got one piece, and then the next piece is half of that size, next piece is half of that size, and the next piece is half of that size. So something like that. And let's label these. So if this is x, this has got to be 2x, this is 4x, and this is 8x, entirely based on what they've told me in the question. Each piece is twice the length of the next smaller piece. So the total is 8x plus 4x plus 2x plus 15 plus x, which is a total of 15x. And they're saying what fraction of the original string, which is 15x, is the longest piece? Well, the longest piece is 8x, so 8x over 15x is my fraction, and the x's cancel, so you're just left with 8 over 15. And therefore, number 17, the answer is A. 6 consecutive integers are written on a blackboard. When one of them is erased, the sum of the remaining 5 integers is 2012. What is the sum of the digits of the integer that was erased? Integers are consecutive, so x plus 1. How many other? 6 of them, right? So x plus 2, x plus 3, x plus 4, and x plus 5. Now, one of these is erased. I don't know which one. And then you take the remaining 5 and add them up, and they equal 2012. All right, so 5 integers are added up to make 2012. So let's just do a little bit of approximating. 5 integers, so 2012, let's just say divided by 5. What does that give me? It gives me approximately 402 point something, right? So the numbers are somewhere around 402. I don't really know. So this is just going to be like trial and error. Okay, so let's say the middle one is 402. Well, there is no actual middle one because there's 6, so let's just make this one 402. 403, these are consecutive, 404, 405, and this one will be 401, and this will be 400. So now we have to sort of fiddle around, play around with this. We've got to remove one of these, and the remaining 5 have to add up to 2012. And after you fiddle around with this, you'll notice that if you remove this guy, and then you add up 400, 401, 402, 404, and 405, you will get a sum of 2012. Okay, so that's all it is. There's no actual formula. It's just sort of a trial and error type of thing. So they're saying, what is the sum of the digits of the number that was erased? Well, this was the one that was erased. It was the one that was taken out. And the sum of the digits are 4 plus 0 plus 3, which is 7. So number 18, the answer is C. In the star shown, the sum of the 4 integers along each straight line is to be the same. 5 numbers have been entered. The 5 missing numbers are 19, 21, 23, 25, and 27. Which number is represented by Q? All right. Well, you got a choice. You can either fiddle around with these numbers, or you can have some sort of a, scientific, way. And I always like the scientific ways, but it's up to you. Whatever you feel is faster. That's my advice on math contests. So what I'm going to do is a scientific way because I have some time. And that is going to be 15 plus U plus P plus 3, the sum of that line. But they're saying that the sum of the lines are all the same. So that is equal to this line right here, the sum of that line, which is 9 plus U plus S plus 11. And that is equal to the sum of this line. Correct? All of the lines have the same sum, 9 plus P plus Q plus 7. And similarly, that is equal to this line right here, which is 3 plus Q plus R plus 11. And finally, is there any other one that I missed? Yeah, this one, 15 plus S plus R plus 7. Okay, so hopefully somewhere in this, it's going to come up with something that helps me. All right, well, let's see here. Obviously, let's look at the first two, these two guys. When I equate them, I get 18, the U's cancel, plus P is equal to 20 plus S. And therefore, P is equal to 2 plus S. Okay, so this P is 2 plus S. And this is S right here. Okay, so far it doesn't really help me, but let's just keep going here. Let's see, where else can I look at I think Q and S. I'm interested in Q, right? That's what I have to figure out. So if I can get a relationship between Q and S, I think that will help me. Is there anything that helps me to get a relationship between Q and S? And yeah, these ones, the last two. So if I take the last two and equate them, I get 14 plus q is equal to 22 plus s, because the r's cancel. So that means q is equal to 8 plus s. Okay, so that means this guy is 8 plus s. Okay, I got it. So if you look at the fact that the numbers are just 19, 21, 23, 25, 27, q is equal to 8 plus s. The only way that is possible with these 5 numbers is if s was 19, and since q is 8 plus s, 8 plus 19 is 27. That's the only way. So that means 19, the question number 19, is 27, and therefore that's choice D. And just for the sake of curiosity, obviously, well, this one is easy. It's 2 plus s, which is 21, and that p there. This is already 19, and then the other two guys, this u is 25, and this is 23. And if you add up all the lines, you'll see that the sums are all equal. If n is the smallest positive integer whose digits have a product of 2,700, then the sum of the digits of n is. The first step in this question is to divide 2,700 into its prime factors. And when you do, you get 2 times 2 times 3 times 3 times 3 times 5 times 5. Yeah. 4 times 9 times 25. Sorry, it was 4 times 27 times 25. This is 27, not 9. Okay, so that's the prime factors. All right. So now what we have to do is we've got to come up with some number n that, I don't know how many digits it is, by the way. They don't tell me that. But somehow, some way, I've got to come up with a number n that if I take its digits and multiply them, they equal 2,700. And it's got to be the smallest possible n. Okay. All right, so let's think about this. The 5s I don't think we can change in any way, because if I multiply any number by 5, it will no longer be a single digit. Like if I did 2 times 5, it becomes 10. And each of these has to be single digits. So I think the 5s we have to leave alone. But the 3s and the 2s can be combined. And the more combinations I find, the better, the smaller the number will be. Because right now, it's a big lot of digits, right? But hopefully I can combine them. How can I combine them? What are the possibilities? Well, let's just work with this. How about 2 times 2? 3 times 3 and then a lone 3. If I do that, 2 times 2 is 4. 3 times 3 is 9, and then I got a lone 3 in here, and then the 5 and the 5. Now, this is, of course, is not the smallest way of doing this. The smallest number with these 5 digits would be 3, 4, 5, 5, 9, I believe. But it doesn't really matter, interestingly, the order, because they just want you to find the sum of the digits. Okay, let's do that. Let's find the sum of these digits. So it's 10 plus 9, 19 plus 7, 26. Okay, 26 is one of the answer choices, but let's see if I can get a better one. In terms of a smaller n, right? Because this may not be the smallest n. So let's go back to my original, and let's see what I can get. Initially, I had done 2 times 2, 3 times 3, and then just a lone 3. Is there any other combination? How about if I go the other way? 3 times 3, 3 times 2, and then a lone 2. If I do that, 3 times 3 is 9, 3 times 2 is 6, and then a lone 2, and then I've got the 2 5s. Now, of course, that's not the smallest way of making these 5 numbers in a 5-digit number. The smallest n would be 2, 5, 5, 6, 9. It doesn't really matter, but I'd like to put it in that form, because in the end, we just have to find the sum of the digits. Okay, what is the sum of the digits here? 10, 19 plus 8 is 27. Okay, now this n is indeed smaller than that n, and I'm pretty sure this n is the smallest possible n. And therefore, the sum of the digits of the smallest possible n is 27. A little confusing. The n is smaller, but the sum of the digits is larger. So number 20, the answer is E.